Hello again. So we'll be solving an exercise related to matrices and especially a doubly stochastic matrix. So we have a matrix and we need to decide whether it's a doubly stochastic matrix. So they are telling us that in mathematics and especially in probability, so a doubly stochastic matrix, also called bistochastic matrix, so it's a square matrix. So we have the number of rows is equal to the number of columns. So we have non-negative real numbers. So all the numbers in the matrix are positive and they are real. So we have some commas. So we need to read a double matrix. So we have also the condition that the sum of each row and the sum of the element of each columns is equal to 1. So the sum in each row is equal to 1 and the sum also in the columns is equal to 1. So we have here an example. So yes, so we have the sum here 0.5 plus 0.25 plus 0.25 is equal to 1. So the same for all the rows and also for the columns is equal to 1. However, for this example, for example, it's not equal to 1 in all cases. So for example, in the rows they are equal to 1. However, in the columns, for example, here we have 0.17 plus 0.84, it's more than 1. So we need to check the rows and the columns. So they are telling us to write a function to check whether a matrix is a doubly stochastic number. So we know that, so we have a matrix. So it's already read, it's already given. So I just need to check if a matrix is a doubly stochastic matrix. So they are telling us that everything is written. So we just need to write the testing part. So also, since we are dealing with doubles, so we don't have the value 1. So they are telling us that the sum of each row and column is not equal to 1 whenever the absolute value of the sum minus 1 is greater than 1 e minus 6, because we don't have correct numbers in whenever we are dealing with double. So whenever it's close to 1, we will say that it's 1, and whenever it's far from 1.00001, we say that it's not equal to 1. And again, we have also a challenge so that we can write the solution using only 2 nested loops. So we'll skip this at first. We'll just write the conventional code and then we'll see what we're doing. So obviously, in order to calculate the sum of each row, I need to loop over the matrix. So to loop over the matrix, I need 2 loops. So for each row, I will calculate the sum. So at first time, we'll do one. So we'll loop over the matrix to calculate the sum of each rows, and then another times we will loop another times in order to do the summation over the columns. So this is not the challenge, and then we will move in the second part. So we will correct that in order to write it using only 2 nested loops. So I need I and j. So obviously I need to loop over the matrix, so the dimension, so it's a square matrix and the dimension is equal to n. So I need to calculate the sum of each row. So I should have, so here it's double because the matrix is double sum row. So at each time before, so this is for each row, I will initialize sum row to 0, and inside the for loop I will increment my sum row and add the value of t of ij. So whenever I'm doing the summation, so I just need to be sure that all the elements should be positive. So if, for example, I have a negative number, I need to stop doing that, because obviously it's not a stochastic matrix, a doubly stochastic matrix. So for example, I can say that if t of ij is less than 0, so I can either use a break or I can use either use a flag. So let's use both. So I will do a flag. So flag is 0. So obviously I need a flag, and my flag should be equal to 1 at first, and I do a break. So whenever I do a break, I will get out from the inner loop. So if I'm here, I will ask, so if flag is equal to 0, also I need to do a break in order to get out of the outer loop. So this is just for rows. This is just for rows. So if ti of j is equal to 0, I will do that. So if flag is equal to 0, there's no need to continue. So whenever I'm finished calculating the sum of the row, I need to check. So if the same as they have asked us. So if the f absolute value of sum minus 1 is greater, so here we don't have sum, we have some row. So in that case, I have a flag equal to 0, and I will do a break. So if the difference between sum row and 1 is greater than that, so obviously sum row is not equal to 1, I will set the flag equal to 0 and I will do a break. So whenever I'm reaching here, so either everything is okay or I have a flag equal to 0. So in order to repeat that on the columns, so if a flag is equal to 1, it means if still so if everything is okay for the rows, so let's check it for the columns. So here we repeat for the columns. So whenever we finish that, so obviously I will repeat that, I can check. So if flag is always equal to 1, so I will print yes or just the character y. Otherwise I will print just no. So however here I need to repeat all this. So let's repeat that. So I will loop over the columns. So for j equal to 0, j less than n, j plus plus. So I need also a variable, so I will call it sum colon, even though I can reuse the same variable, but let's call it sum colon. So sum col, I will initialize it to 0, so I will do that each time I'm looping over a newly discovered column. Then I will loop over the row I plus plus, and I will repeat the same stuff. So if I will do the summation equal t of I j. So as you can see, j is fixed and then I is moving. It's not at the same here. So j is fixed, so for the column 0 for example, and I is moving 0 1 2 3. So I will copy that because it's the same. So if t of ij, so I can also omit this because we have already looped over that, so I can omit this. So there's no need to recheck if tij is negative, because if it's negative, we've already passed that by it here. So also there is no need to do a flag equal to 0 because I will get out and check the flag if only there's a negative value. So I just need to check after finishing the loop if the sum is correct, yes or no. So if the sum colon minus 1 is greater than 1e minus e, so I will set flag to 0 and I will do a break. So break, so if is in this, so the break is in this for loop, so I will get out from this loop. So let's do a pre-check. So yes, let's do a check and see if everything is correct. So everything is correct. However, we didn't satisfy the challenge because here we have used two nested loops. The first two nested loops we have looped over the rows of the matrix, and in the second set of the two nested loops we have looped over the columns. However, so if we are a bit wicked, so if I'm looping over a row, so let's suppose this is t. So we know that this is t of 0 0, t of 0 1, and this is t of 0 2. And for this one, t of row 1 0 and t of 2 0. So if you can see, if you are looping over the first row, you can at the same time loop over the first column. So why? Because here we have 0 0, so this is I is fixed and j is moving. So I is equal to 0, so this is our row and j is moving. So whenever I have, so let me recopy that, 0 0 0 1 0 2. So at the same time in the columns I have 0 0 1 0 2 0. So as you can see, as if we have introverted the index I and j. So at the same time, I can do the summation of the row and of the columns. So in order to do that, obviously I will remove all these, I will erase it, and I will keep the sum row and sum column. So at each time, I will initialize sum row to 0 and sum column to 0. I will loop over j, I, j equal to 0, j less than n, j plus plus, and I will do the sum column. So in the sum column is equal to the introverted form, so t, j of I. So why? Here we are looping over each row. So I is fixed and j is moving. So if I go back here, I have placed j at first. So j is moving 0, 1, 2, and I in the second dimension is fixed. So now at the same time, I'm calculating the sum of one of the rows and its corresponding column. So if t of ij is less than 0, obviously I will get out of the loop. So if the sum absolute value of the sum row is greater than 1, and or the absolute value of the sum column is greater than 1, I will do a break. So in just 2 nested loops, I have reached to do the summation of a row and a column. Because it's a square matrix, I have checked if it's negative, I have get out of the loop, the same, so I have rechecked the flag, and whenever one of the sum of either the row or the columns is greater than 1, I will get out of the loop. So let's do a pre-check. So there's no error, so let's do a check. And it passed again. So the idea was to just use 2 nested loops and to do the summation. So this is the trick here. So if I'm doing the looping over the rows, I can access the column also by introverting the indexes I and j. And this is it for this exercise. So if you have any questions, do not hesitate to write to me or use the forum on Moodle. And do not forget to subscribe to my channel. And again, thanks for watching.